think we are live. Okay. Able as well, I believe. Hi everyone, to another session. So today also we'll be solving two problems, and after that I'll be giving a few problems out for homework. So make sure you are solving them as well. Right. Let's directly get started with the first problem. Right. The first problem is count pairs with the given sum. So we are given an array of n integer and an integer k. Find the number of pair of elements in the array whose sum is equal to k. Right. So we are given an integer k, and we have to find the number of pair of element in the array whose sum is equals to k. Right. So for example, k is equals to 6. So 1571. How many pairs are there with the sum equals to 6? So 5 plus 1 is 6, and again 1 plus 5 is 6. So there are two pairs with the sum equals to 1. Right. So we have to return 2. Similarly, 1 1 1 1, and we have 2. So how many pairs are there? Hashing. Okay. How many pairs are there with the sum equals to 2? So we can get these two. 1 2. Again we get 1 2 2 pairs, 3 pairs. This one and this one, 4 pairs. This one and this one, 5 pairs. This one and this one, 6 pairs. Right. Uh, 6 pairs. So there will be 6 pairs total. As Avinash has said, it's very similar to, yes, it's exactly hashing only. We have to do, but let's see how we can do that, right? So what we have to do, we have to count the number of pairs with that sum. Okay, let's quickly see the constraints that is given to us. Order of n time order of n, right? So yeah. So what we can do is we can maintain a hash map. Now, what do we want exactly? We want this thing, right? A of I plus A of j equals to k. Number of pairs ij such that a of I plus a of j equals to k. Let's say we have fixed a given value of I, right? So what does it turn into? A of I plus a of j equals to k. A of I is fixed, right? So what is a of j? A of j is variable, j is variable. So a of j equals to k minus a of I. A of j equals to k minus a of I. So what we have to find is number of elements, number of j's that are there, such that a of j is equals to k minus a of I in the array. So how can we do that? We can maintain the frequency of all the elements. Like whenever we visit an element, or whenever first of all we'll maintain a frequency of all the elements. So f of a of I plus plus in a hash map, right? So we'll have all the frequency of all the elements, and after that we just have to search for, given a of I, what do we want to search for? How many subarrays are there that contains a of I and has a sum equals to k, right? So for this thing, what we can do is we can do, first of all, one thing we have to make sure that if, let's say, a of I is equals to k by 2, a of I equals to k by 2, that case it might happen that we are counting this with itself. So we have to make sure that this is not there in the hash map. So we can reduce its count in the hash map once, and then again once the operation is done we can increment the count again. So that's one way we can do. So what we can do is number of pairs will be how many? You can just search for f of k minus a of I, because that will give the a of j's, right? Number of j's from the hash map, right? And finally, if you look into this carefully, we would have calculated each pair 2 times, right? We would have calculated each pair 2 times. One, because one time, like let's say ij is a pair that sums up to k. One time I is pointing to this, one time I is pointing to this. So both the times we are including it in the answer. So we have to divide the answer by 2. So that's one way of doing it, right? A better way to do it is to make it in incremental way. So let's take an example and understand this second way. That's also same, like it's also hashing, but what we are doing is we are not direct. First of all, we are not actually counting the frequency, rather we are maintaining a running frequency. Why? What would be the advantage of that? In that case, we are restricting, like we are just restricting that I, let's say ij is a pair and you are fixing I, right? So you are restricting that j is less than I. You are restricting that j is less than I. In this way, every pair is counted exactly once, and you do not have to take care of things like subtracting a of I from the frequency table and those things, right? So you don't have to take care of those things, and this is a better way, right? This is a better way to do. So let's actually understand with an example about this. How can we do this? So 1571, right? 1571. We'll understand in both ways, right? We'll understand in both ways how we are doing this. So 1571 is the array. First of all, let's talk about the first method. So this is the hash map that we have. So frequencies will maintain. 1 has a frequency of 2, 5 has a frequency of 1, 7 has a frequency of 1. Now we'll visit all the elements one by one. So once we visit 1, what do? We first reduce the count of 1 here. So reduce the count of 1 to 1. Now you see what is needed. K is 6, K equals to 6 is needed. So what is needed from the frequency table? You need a 5 to get 6, right? So you just do 6 minus 1, that is 5. So 5 is needed. What is the frequency of 5? 1. So answer plus equals to frequency of 5. So answer becomes 1. Now you add this. You had subtracted 1 here, right? Because current element is 1, you add it back. So this will become 2 again. Go to the next element for 5. Okay, for 5, you have 5 right now. Subtract the occurrence of 5 definitely. So reduce the count of 5 to 0 right now. Okay, now what is it that you need? You need a sum of 6. So what is the remaining value that you need? 6 minus 5, that is 1. How many ones are there in this array? The frequency is there 2. So answer plus 2, right? Answer plus 2. Now 5 is done. Introduce 5 back into the hash map. So introduce it back here like this. Next, go to 7. With 7, you cannot get anything because what you need is a negative number. So that's not there in the array. So you go ahead. 1. Again for 1, you reduce the count for this 1 to from 2 to 1. Now what you need is 5. So you do a plus 1. So you get 4, right? So the answer will be 4 by 2, that is 2, because you've calculated all the pairs once, 2 times. Like 1 5 is calculated 2 times, 5 1 is calculated 2 times. So that's why it was 4. So you will do answer by 2. So this is the first way, right? This is the first way. Let's talk about the second way. In the second way, we do not pre-compute the frequencies, right? We compute it in a running fashion. We compute it in a running fashion. So what we'll do here is 1, we'll increment the frequency here. First of all, we'll see what do we need. We need 5, right? For a sum of 6. For a sum of 6, we need 5 more. Is 5 there in the hash map? No, right? So we will not do anything. We will just update the frequency in the hash map. 1 is 1. Next, we'll go to the next place. 5. So what do we need? We have 5 already. The next element that we need is 1. Right? 6 minus 5 is 1. Is 1 there in the hash map? Yes, it has a frequency of 1. So add that to your answer. So answer is added to 1 and update the frequency of 5 here to 1. Next, go to the next element, 7. So what you have is 7. What do you need? Minus 1. Is minus 1 available in the hash map? No, right? So you go ahead. You update 7 here in the hash map and go ahead. 1. So what do you have right now? 1. What do you need? 5. So 5 is there. Yes, it has a frequency of 1. So add the frequency 1 here and you get an answer of 2 and you update the hash map here like 2, right? So answer becomes 2 and you see that you are calculating paired only once. So what is the complexity? The complexity, you are running only one group. So the complexity will be order of n time complexity and order of n space complexity because of this hash map. So that's it. And let me know if you have any doubts. We can quickly write the code for this. Pretty simple problem. So unordered map. So I'm using an unordered map, right? Because if I use a map, it will add a logarithmic complexity mode. Map is not a hash map. Map is a tree map. It's not a hash map. It's a tree-like structure. Hash map is unordered map. It has a order of 1 frequency because of hashing, but there is chances of collision as well. So that's there. So answer equals to 0 for int I equals to 0, I less than n, I plus plus. The frequency of k minus ARR I greater than 0, answer plus equals to frequency of k, and then you do frequency of ARR I plus, finally return answer. So this much code is only needed. So let's try to run this, compile and run. So we are getting the expected output. So let's submit this. Okay, so this is working fine. Okay. I'm hoping that you don't have any doubts. It's a pretty simple problem. Now here, if you don't want to use unordered map, just check this value of ARRI. Every ARRI is within 10 to the power 6. So you can actually create a array of size 10 to the power 6 and have maintain that as the frequency table or the hash table, right? So you can just maintain that, and that would definitely fit the constraints. But we have used unordered map because yeah, it would have worked fine. Anyways, let's move ahead to the next problem. Okay, this one is a good problem, and I have also not solved this. So let's actually solve this together, right? So yeah, I might be making some mistakes, but again, like, just feel free to correct me, or if you have some idea, just throw it. All right, but let's see. So the problem that we'll solve right now is maximum product subarray. So you're given an array ARR of n integers, maybe positive, negative, or 0. Find the product of the maximum product subarray. So you have to find the product of the maximum product subarray. Now the elements can be positive, negative, or 0, right? For example, 6, 3, minus 10, 0, 2. What is the maximum product subarray that we can get? So we can get this one, 6 minus 3 minus 10. So it will be 30 into 6, that is 180. 180 is the maximum. But if we extend it to 0, it will become 0, right? So we cannot include this 2. So this is the maximum product subarray. Now what we want to do is we want the order of n time complexity, order of 1 space complexity. All right. So that's what we want. Okay. Okay. The problem is clear with everyone? Let me know if you have any doubts with respect to the problem statement. Anyways, what we can do here. So we want the order of 1 space complexity. That's interesting. So what is coming to my mind first is, what's coming to my mind is we only want even number of negatives, right? We always want even number of negatives because that will give a positive result. Even number of negatives. Second thing is avoid zeros, right? So avoid zeros. So whenever we have a 0, right, whenever we get a 0, we should definitely like just consider, like, break it into multiple subarrays across zeros, and our answer will definitely be within one of these subarrays, right? It would not cross between the two subarrays. So whenever there is a 0, we have to avoid that, right? So we have the flexibility to break the array into multiple subarrays against the zeros, right? So that's something that we are getting rid of. Now what we want to do here is, we want to know what is the maximum product that we can get. Now actually see, whenever you are multiplying something, right, let's say 3 into 2, the product is always increasing, right? The product is always increasing whenever you are multiplying something. So it's always better for us to multiply things, right? But the only issue is for negative numbers. Zeros we have tackled, right? Zeros will split it into two parts. Like zeros, like, we'll treat it as multiple arrays, and whenever there are zeros, we'll just we are getting rid of all the zeros. We are splitting the array across zeros, right? Now coming to the negatives, the only thing problematic is 30 minus 2. That would give me minus 60. But let's say there is one more minus. Let's say minus 3. That would give me a plus 180, right? That would give me a plus 180. So it's always better. It might be better for us to have zeros as well. So sorry, to have minuses, negatives as well, because two negatives will then turn out to be positive. So my idea will be that instead of actually considering the actual values, right? Instead of considering the actual values, we can just consider the parity. That is, element is positive, it will be treated as 1. Element is negative, it will be treated as -1, right? -1, -1, 1, 1, -1, something like this. So we have to find in this what is the, and again, like each has some weight, each has some value as well. So for every index, if we can find for every index, if we can find that what is the maximum subarray, what is the maximum subarray that ends at this index and has the maximum product, right? So this, what we can do is we can find what is the maximum position where we do not have any -1. What is the maximum point where we have even number of -1 or even number of -1? So that's something that we want. Now yeah, we can definitely do it in multiple ways. That's definitely there. Like we can maintain a frequency table, but again, it turns to be order of n, right? It will turn out to be order of n. So again, like it's always better. Like see, there are let's say there are multiple -1 before it, right? There are multiple -1 before it. It's always better for us to choose this one, right? We could have chosen this one as well. It's always better for us to choose this one because this will cover more number of elements and their product will definitely increase, and we are getting a positive result as well, right? Because 2 -1s are there. So we have to choose the farthest possible -1, right? So farthest possible, like farthest possible even number of -1, that's what we have to choose. Okay, so on the left hand side, so that's there. What can we do about this? That can be done using a hash map, but we want the maximum value now. The maximum value definitely we are getting, so here we just have to find the product of these elements. But again, like if we are will the sum, can the sum exceed long, can the product exceed long? And also we cannot use a prefix, right? We cannot use a prefix. So that's there. Okay, let's do something like this. Let's use something similar to Cadence algorithm, right? Because in Cadence algorithm as well, we are having a similar concept that we have max sum till now and max result, and we see that if we can extend the sum till now to contain the product. The only problem here will be the product might become negative, but again, like it might become positive after getting a negative element after that, right? So it's always better to have that. So what we can maintain is we just need two things, right? We just need two things. What is the max, sorry, what is the max negative product till now? What is the max positive product till now? Right. So max negative product is what is the maximum negative product that we have seen till now. What is the maximum positive product that we have seen till now, right? Whenever we get a element that is greater than 0, right? If the element is greater than 0, so max negative product will be updated as max negative product into equals to ARR of I. Max positive product will also be updated as into equals to ARR of I, and our answer will also be updated, right? Our answer will also be updated. Now when we get a number less than 0, now this negative portion is becoming a positive, and this positive portion is becoming a negative. So we have to interchange, right? We have to interchange between the negative and the positive values. And whenever we get a equals to 0, we just have to reset this to 1, reset this both of them to 1, because you cannot cross a 0, right? You cannot cross a 0. So we'll use a very similar approach to Cadence algorithm, and I think that should work, right? That should work. Let's understand this with an example, and let me know if you have any doubts or if you have any better solutions or suggestions. So 6 minus 3 minus 10 0 2. I think that should be easy. Yeah, yes. Let's have that one. 6 minus 3 minus 10 0 2. 6 minus 3 minus 10. So okay. First of all, max negative is 1. Max positive is 1, and result is equals to 1. Result equals to 0 also you can keep same thing. Result equals to, okay. You start off at 6. So is 6 a positive number? So you increment, update both of them, and you update this to max positive definitely. So 6, this will become 6. Res equals to max of res comma max positive. So this will become 6. Next you have minus 3. So when you have minus 3, the max negative will become into equals to 3. So this will become minus 18. Okay, you have a minus 3, right? You have a minus 3. So actually, when you have a 6, you do not update max negative. Should you update max? Yes, you can update max negative because you're starting at 1, right? So that should work. So minus 18, and that you have to update, right? Because there will be, there can be multiple of. So anyways, minus 3, so it will be minus 18, and this will also be max positive will be 6. Max positive will be 6, and we are not considering this yet. Okay. Or we can reset max positive to 1 because we are breaking out here, right? If we are breaking the subarray here, so max positive we can reset it to 1, I believe. Let's come here to minus 10. Now when we come to minus 10, what is the max negative that we can get? Max negative, max positive, it will be into minus 10, right? So we know that we have to interchange here because it is negative and it is also negative, so max negative becomes max positive now. So 180, it will come to max positive, and max negative will become max positive into ARR of I, that is minus 10. 1 into minus 10, that is minus 10. And see, that's why we reset the 6 to 1, because otherwise it would have become minus 60. Be wrong, right? So and we'll update our answer to 180. We'll update our answer to 180. After that we get a 0, right? We get a 0, so we don't we reset everything, right? We reset this to 1, this to 1. Again we get a 2, so we reset this to 2, we set this to 2, and this is not updated. So the answer we get is minus 180, right? Answer we get is minus 180. Let's look into a better example, and let me know if you have any doubts. Let's look into a better example. Let's say we will have some negative elements. 2, minus 3, 4, 5, minus 6, 7, something like this, right? So again, max negative, max positive. Initially both of them will be 1, and max. One corner case will be all the elements are 0. In that case, we have to handle that separately. But yeah, let's start with this. So max negative is 2. So we'll multiply 2, we'll multiply 2 here, and max becomes 2. We'll go to minus 3. Now when we have minus 3, what do? We reset max positive to 1. Max negative to 2 into minus 3. 2 into minus 3 will be 2 into minus 3. Okay, max negative. Now when we have a negative element, when we have a negative element, we have 2, right? When we have a negative element, we'll swap these two, right? We'll swap these two and multiply this. So swap these two, minus 3, minus 3. So it will become 6. It will become minus 6. Swap these two, 2 was there, and then you multiply minus 3. So to the negative, okay, to the negative you multiply minus 2. Yes, you multiply minus 3 to the negative. And for the positive, okay, for the positive, this will be a bit challenging one. We have 2 here, right? Let's see, we have a negative number. Now max negative, actually this should be set to 1 only. Then otherwise it will be a problem, because we are having a negative, we are having a positive, we are having, like, we would have carried forward. So now see, max negative, max positive will interchange. So it will become 2, 1 first, 2, 1, and then minus 3 will be added to max negative, so minus 6, and it will remain 1, right? Because the max negative here is so we'll go to the next element, into 4. So max negative, again max positive is done into 4, max negative minus 6 minus 24. Next we have 5. So again into 5, into 5, into 5. So this will become 20. 5 is 20. We have negative again. Now again in negative, what do? We swap first, minus 24 into 5 and 20. So minus 24 into 5 and 20. Then we add the negative, that is minus 6 and minus 6. So this will become positive, minus minus will cut out, and this will become positive 24 into 30. And also this will become a negative, right? See, the maximum positive negative till now will be 4 into 5 into minus 6, right? That is 20 into minus 6, that is 120, minus 120. And after that we have 7, so 7 will be added to both of them, multiplied, and you get the answer. So that's the logic. It is very similar to cadence algorithm. Basically we are extending cadence algorithm for multiplication. So let's try to do this. I hope that this will work. So long max negative. equals to 1, max negative equals to 1, max positive equals to 1, for and int answer equals to 0. So answer equals to 0. And also let's maintain a flag, bool flag, or I think that's for int I equals to 0, I less than n, I plus plus. So first case that will handle is if error of I is equal, and that should actually not update our answer, right? So we'll set max negative to 1 and we'll set max positive to 1 and we'll continue. Otherwise, what we'll do if error I greater than 0, in that case max negative into equals to error I, max positive 2 equals to error I. And else if it is less than 0, if it is less than 0, in that case what should happen? It should be swapped first. So swap also, let's update our answer here as well. So answer equals to max answer and max positive, and swap max negative and max positive first, and max negative 2 equals to error I, max positive max negative and max positive, yes, max negative equals to and max positive into, so this will become positive now, and answer equals to max answer and max positive. So finally we can return answer from. So we are running a single loop and we are just using temporary variables, so that should be order of 1 space complete, order of n time complete. Let's try to run this. Int answer is there, so it should be long. It's expected. Let's submit and see if this is 1 minus 4. Output is 0, correct output. Okay, if there is one element, haven't handled. If there is only negative element, let's do one thing. Answer equals max max negative, but again, like, it will be set to 1, right? If it is set to 1, so that's something that I don't want. Can this be like only negative element? Negative is there, it will become positive, but if a negative is there and after that a positive is there, so we can have a positive. Okay, that should be a positive. What we can do here is, what are we doing on negative? Max negative, max positive, max negative and max positive, we are swapping. We are only updating error I if max positive is less than 0, then only we should do max positive into equals to error I, else max positive equals to error I. If it is greater than 0, so in that case it should be equals to error of that should be there. Max negative should be okay, max negative error, right? Okay, and in case this one, so in that case, we talked about a case, right, where we not think so. Max negative, we have a negative number. Yeah, right. So I think case it should. Okay. And finally, if answer is negative, like if n equals to n equals to 1, return error, return long, return long. That should be uh that. Let's see if that's what I might need a lot of price for. I don't think. Minus 8531. How did it not give me out? So we had a minus 8 here. Okay. Initially, see, let's actually dry run this. Minus 8531. Let's try to dry run on. what are we doing? Minus 8 minus 8 5 3 1, right? So initially our max positive is 1, max negative is 1. Now we have ARR I less than 0. First of all, we swap so nothing happens. After that, max negative into equals to ARR of I. So max negative into equals to ARR of I means max negative becomes minus 8. Max positive is less than 0, no. So max positive is equals to ARR of I. So max positive becomes minus 8. Okay, that should not be, right? Max positive should become 1. Should remain. So, okay, it is a negative number. Max positive is less than 0. Otherwise, max positive, I think that should be. So, max positive equals to 1. It should be because, again, like if it is greater than 0, so you're making max positive a negative number. So, that doesn't make sense. Anyways, yeah, this is the code. Let me know if you have anyone has any doubts. If you have any doubts on this. We have solved it very similar to cadence, and we see that we can extend cadence to multiplication as well. That's also interesting. Yeah, let me know if you have any doubt. So this is the first time I'm also solving this problem. If you want to know how did I get the intuition, mostly around the fact that we have to, like, it makes sense, right? That two negatives are becoming positive whenever we have 0, we are actually resetting everything. So it kind of makes sense that it looks similar to cadence algorithm where we find the maximum sum of a subarray, right? So we are extending the existing to the new one. So it's also kind of similar that you have a new element and you're extending the existing answer to the new element. That is what you have to do. And you here it makes more sense to keep two of them, because in cadence generally we discard whenever it goes less than 0 because there's no benefit of that. But here less than 0 also has benefit, right? Because one negative comes in and that might actually overshoot. So we have to keep both of them. So that was my intuition behind this. And yeah, anyways, let's quickly discuss about the homework problem. So the first problem that is there for your homework is, I think I've discussed this, I'm not sure, but whether it's in Amazon series only or if it is somewhere else, but definitely in this channel you have a video around this. So it's you have to find the max number row with maximum number of ones. So you're given a boolean 2D matrix, and you have to everything is 0 based. You have to find the row with maximum number of ones, right? And you have to do it in order of 1 space complexity, order of n plus m time complexity. It's pretty simple, but it's a nice trick that is there. I've already discussed this, so you can check the videos as well. Second is frequency of limited range array elements. It's a easy problem. So you're given an array of n positive integers which can contain integers from 1 to p, where elements can be repeated or can be absent from the array. Your task is to count the frequency of all the elements from 1 to n, right? And that's there. And order of 1, you have to do it in order of 1 extra space. That's the challenge. So try this as well. And smallest positive missing number. So you're given an array ARR of n integers including 0. Your task is to find the smallest positive missing number, order of n, order of 1. Merge without extra space. So you have to merge sorted arrays. Each array is sorted in non-decreasing order, that is increasing order. Merge the two arrays into one sorted array in non-decreasing order without using any additional extra space. So these are the three problems, and this is the complexity. So these are the three problems that or four problems that you have to solve. Some of them are pretty simple, some of them are good. So I would recommend you to try these, definitely try these problems, right? And one more update from for the next week, I'll not be available. I'll be shifting. So yeah, we'll be resuming from next to next week. So in case if you're wondering like joining the class next week, don't, because the class will not happen next week. But yeah, it will resume, I believe, either next to, yeah, it will resume on next to next. All right, that's all I had to discuss for today. Try to solve these problems again. Do with max number of ones, frequency of limited range array elements, smallest positive missing number, and merge without extra space. So definitely solve these problems. It will definitely help in your interview, right? So yeah, I want to end my class here today. Thank you guys for joining in, and we'll be seeing you next to next. So yeah, we'll be seeing you.